Good afternoon. All of us know that when matter is heated, it expands. Have we any time noticed when we are having a cup of coffee in a steel tumbler, can we see the change in its size? No. When you boil water in a kettle on a gas stove, do you watch it and find that it is expanding? No. How do the children believe that yes, expansion is taking place in those cases? I would like to show that in a small demo with material made at home. Please watch the pointer over here. The pointer is moving over the scale. Right now it is at 62.5. Maybe after a couple of minutes, I will see the reading once again. Please remember 62.5. What have we done here? The experimental rod which undergoes expansion due to heating is over here. It is roughly 15 centimeters. One of its end is fixed while the other one is open and it is free to expand. For expansion to happen, there has to be heating. So we have two mica heaters kept coaxial, and this is being energized by a dimmer which is kept at 90 volts for getting a particular heating rate. The maximum temperature that these mica heaters can obtain is 480 degrees centigrade, and the intensity of heating is 3 watts per square centimeter, and that is good enough for our purpose. To note the temperature, there is a temperature sensor which has a thermocouple at this end, needs to be kept close to the rod, and the corresponding temperature can be read over here. This will give us the corresponding temperature of the rod while it is being heated. The sensor is having an uncertainty of 1 degree centigrade, but the sensitivity is plus minus 0.1 degree centigrade. So it is a good temperature recording which will give us small changes in temperature. This heating, when it heats, this will expand on the right hand side, and this expansion is fairly small for this sample. This is a ferritic stainless steel 401. Its thermal coefficient is 10 in 1 million per degree centigrade, which is absolutely small. So in a naked eye, if you increase the temperature by 1, 2, 3 degrees or even 100 degrees, the extension will be so small that you cannot observe it in your naked eye. If you want to increase it, probably take 100 centimeters length and increase it for 100 degrees centigrade. You have to wait for sufficiently 2 hours or 3 hours for you to obtain a small expansion of about 0.1 centimeter, which is very small. So it has to be an expansion which should be noticeable by students in the classroom, and that is possible only by making or expanding this expansion sufficiently high for the students to observe in a couple of minutes, and that has been done over here. For expansion of this for noticing this expansion, there is magnification possible by using two levers. This is lever 1 and this is another lever 2. The first lever is pivoted at the point behind this wooden stud, and it is resting on the free end of the rod. The distance between the pivot and the point where it is resting is roughly about 2 centimeters. We have measured it. While the overall length of this lever is about 30 centimeters. So when this expands through a small distance x, this lever rotates like this and moves through a distance 15 times x because of its dimensions. There is a second lever which is pivoted at this point, and it is again resting at the free end of this lever 1. This distance is 1 centimeter, while the overall length of the second lever is 40 centimeters. So when this shifts through 15x, this point shifts through 40 times 15x, which is 600x. And therefore, if the small expansion x is not noticeable, 600 times x will be noticeable on the scale that has been placed just behind this. You can see it right now. The reading is 64.2. So from 62.5 it has come to 64.2 within probably a couple of minutes. Of course, the temperature I'm not recording right now, but you can record the temperature simultaneously. Therefore, the expansion is visible, and I'm sure you have realized that the pointer is moving in the noticeable fashion, and hence you can realize that there is expansion happening at this end. This is not only a demonstration apparatus, you can use it for quantitative measurements. I have taken a set of readings and tabulated over here. You can have a look. Thermal coefficient is defined as the change in length to the original length to the corresponding rise in temperature. Alpha is equivalent to delta L divided by L delta T. So for noting down all these values, I have noted the corresponding time intervals after every 5 seconds. I have noted the corresponding temperatures and the pointer readings, the pointer positions over here. And from this, I have plotted two graphs. The first one is between the change in length versus the change in temperature, which turns out to be a straight line. And from that, we have calculated the thermal coefficient to be 8.7 into 10 to the power minus 6. And the literature value is 9.9 into 10 to the power minus 6. Fairly good agreement within experimental error. The corresponding standard deviation was only 0.9 into 10 to the power minus 6. In addition to finding out the corresponding thermal coefficient, we've also noticed the heating capacity of my heater by plotting a graph of change in temperature versus change in time, which also is almost a straight line, and that shows that the mica heater at this voltage is heating at 2 degrees centigrade per minute. The schematic diagram of this apparatus is over here, which is showing the end of this rod. This is your first lever, which was touching the end of the rod, and after expansion it has gone to the solid line. The second lever was touching the first lever at this point. The dotted line is the original position and the solid line is the final position. The reading from the scale will help you in finding out the coefficient of expansion. Okay. Now this is an apparatus which can be used in the classroom to show demonstration, and probably the children will realize what expansion means and how it happens, and therefore they can relate it to present real thing life. Thank you. We saw something about linear thermal expansion. In that demo, the rod expanded because of heating. Let us apply it to elsewhere. Here is a ring with a handle and there is a sphere. The sphere has a diameter smaller than that of the inner diameter of the ring. That is why very clearly it goes in and out without any problem. Now let us heat one at a time. I've heated this sphere. Let us do that action once again. Oh, it's not going in. What do you think happened? It's not going anymore. It's not going inside. Can I get an answer from you? Heat expands matter. So that is why the sphere expanded. The diameter became much more than it was originally, and therefore it cannot go through the hole because I have not done anything to the ring. Heating the ring alone and keeping the sphere away from the heat. I'll wait till it is red hot. heated it till it is red hot. Okay. Intuition says that the ball will remain as it is, but the inner ring will become smaller, as a result of which the sphere will not enter the hole. Let's check what has happened. Oh no, the sphere is happily going inside the ring. There is absolutely no problem. So it actually means that the ring has become larger in diameter, both the internal as well as the external circle. Why is this happening? We just now realized that linear expansion is expanding linearly on either side. If that is what it is, then this length should have increased this way as well as this way. Therefore, the inner ring should have become smaller. If that is so, the ball should not have gone in. But now we see that the inner ring diameter is also bigger than it was. The outer ring is also bigger than it was. That means there has been expansion this way. What do you think is the reason if this is correct? This is correct because the sphere is not going in. And where do we use this? This matter is made up of atoms. Two consecutive atoms or atoms which are close to each other effectively behaves like as if there is a spring between them, and these are vibrating. When the temperature increases, this vibration becomes even more, and therefore instead of vibrating like this, they are vibrating much more, and therefore the center of mass of this is not symmetrical. Since the vibration is for a longer distance, all these molecules which were vibrating have now started vibrating like this, and therefore the center of mass has gone much more than the previous position, giving rise to a larger diameter, both internal as well as external. This simple ring which has expanded its diameter is used in the case of bullock cart wheels, where a metal ring is fitted on a wooden wheel by expanding it, and after you let the ring fit the wooden wheel, if you leave it for sufficiently long time, it cools and it contracts and makes a tight enclave onto the wooden wheel. In this experiment, let us watch what is happening to air when it is heated. So for that, I have taken 3 containers. This is the empty container. Is it empty or is it full of air? I'm sure you will tell it is full of air. It is not empty. And then I have another container which I want to use it as a reference. I have added some colored liquid into this. The third container is graduated in milliliters. I have marked some lines over here with the help of a 20 ml cup. So these markings over here refers to 20, 40, 60, 80 and so on. This whole bottle is 565 ml. It is graduated on the side. Now what I will do is fit this bottle over here for convenience so that it does not move. Now I will close these containers with their corresponding cap. The first cap is having one hole which is sealing the air kept inside the container. The second bottle has 2 holes. One of them is connected to the first container and the second one is inserted into the third container. Watch what is happening, then we will realize and discuss upon it. I am pouring some hot water into the container to make it a hot water bath. Please watch. look at the last container. The air that was present over here is obviously expanding. It is going through this pipe. It is pushing the air into this container and therefore developing a pressure difference, and the liquid is coming out into the third container. I hope you have observed it. The amount of liquid that is come over here is 20 ml. The original bottle in which air was present is 1300 ml. Can we find out the coefficient of expansion of air from this experiment? Please suggest. Coefficient of expansion, volume expansion of air is defined as the change in volume divided by the original volume into the rise in temperature. The air was at room temperature, which is 24 degrees centigrade. I added hot water, which is at 80 degrees centigrade. Please calculate and find out mentally. Thank you. Let's watch the liquid expanding. In this tube, I filled it up with liquid. It is sealed at both the ends, except there is a capillary tube inserted into this cap. The capillary tube right now is empty. So the volume of liquid is the volume of this tube alone. I'm dipping the tube in hot water. Watch the level of liquid over here. That is the expansion of liquid due to heating. The level of liquid is over here. Initially, the capillary tube was empty. So in this module, we have visualized the expansion of solids, gases, and liquids. Thank you very much for watching the video.